Good evening for the ones who are there. Can you hear me? The platform is for nursing group. Biochemistry 2, metabolism. Are you there? Karen, if you're already there, let me know. Whoever is there, just let me know. I can't see on my phone, but I think on the laptop, I can't see as well because I'll use the laptop to explain on the slides. So if you can hear me, maybe you can just answer that you're there, or it's a chat. Possibly, I think it's a chat. Because I need to introduce glycolysis as the group requested that I should have time with them. Because if you don't have quorum, then we'll do it weekends. Since tomorrow you have a class. If you have a class tomorrow, we can reschedule it for Saturday, because we need a quorum. I'll not teach a few individuals because it's a class of 65. Good. Who has logged in? Just tell me, Karen. It's nursing, Biochem 2. Anna Mohammed, don't ask me who the hell I am. Huh? If you think you are in a wrong platform, just log out kindly. Anna Mohammed, just leave, please. Don't try to be a bit rude. Huh? We are here to learn. So if you think you are in a wrong platform, just log out. It's still okay. I'm here with the nursing students, metabolism. Just chat and let me know if you're already there, nursing students, Biochem 2. because I need quorum. If we want to be at 30, then definitely we can reschedule it, because tomorrow you people have a class. Good. Maureen Kimathi, you're present. Thank you. Tell them to keep on logging in. We need quorum. Please, Anab, you can log out. If you're in a wrong quorum, just log out. But don't comment rudely by asking me who I am, because you are the one who has come on board wherever we are. So just log out if you feel you shouldn't be here. Yes, please. Frederick is present. Just log in. I need quorum of 30 students from the request of the students. Good. Irene Mikali, just tell me you are present. When we are at 30, I'll start, because tomorrow you have a class. I don't want to interfere with your normal programs. Then we'll be able to reschedule it on Saturdays. Still the same time. But for now, kindly tell me when they're there. Yes, Jeb Korir, you are there. Thank you. They are present. Just log in. Tomorrow you still have a class. I'm waiting for quorum. Good. Keep on logging in. Sharon Eboso. Karen, yes, I can see you. Karen, tell them to log in. I'm waiting for 30 because the class has 65. Lokale, you are there. Are you still doing Biochem 2? Lokale? You are still at Biochem 2? Yes, I want us to be together because the students requested, and now I have to come on board as a mother, not as a teacher, because you feel the pain of the students. Good. I can see Lokale. Thank you for that. So I have to come on board and you explain much on whatever you are given in the PDF. We'll be able to understand and we'll pass. So it's just to sacrifice your time and my time so that we can pass. Good. Rusty, you are there. You know, the names which are appearing there is what I know, but I appreciate. We are almost at 30 because our class has 65. The nursing students are 65. So if we are halfway, we'll start because we can't wait for everyone. Oh, Eutrophia, I can see you. Welcome. We can't wait for everyone. Tomorrow you still have a class. You still have classes. It's a weekday. We might reschedule it for weekends, but now I thought I should start a bit earlier so that we can as well try to understand in the 2 days what we've learned today. Good. We are waiting for eight more. We are waiting for 8 more. Then I'll start. Hoping that you got the lectures. Mohamed Amin, thank you. Hi, I can see Ndungu and Eva Kaume. Good. Thank you so much. Let's keep on logging in. I'm targeting at 30. Then I'll start. Shama, yes, I can see you. Barak, good. Still Anne, yes, Anne, happy to see you too. I'm looking at 30. At 30, I'll be able to start. Hope that you got the... No, don't ask unit registration here. Goni Games, don't ask unit registration, please. Cheryl present as well. Yes, yes. And Dungu, you are together with Cheryl. Thank you so much. So it is for nursing, biochemistry 2. The other group which can log in is oral health, biochem 2, if they're on board. So we are doing metabolism. There is a part which I've introduced the oral health as biochem 2 as well. So if they're there, but here I'm not answering any unit registration, please. Kanchan Mahi, good to see you too. Thank you so much. We are looking at 30. We are targeting 30. Hoping that whoever is logging in are nursing for biochem 2, because I would like to introduce glycolysis. Comfort Chevet, present. Thank you so much. I'd like to introduce glycolysis, then I'll stop. I'll go bit by bit until you understand it. Not only today, but just a little bit. I plan to be here for only 1 hour because for metabolic pathways, we need time to understand. Not even cramming. We need to understand what it's all about. So we are going to move together. Mahi, thank you so much. Good to see you too. Happy New Year. We are still at 24 because I can wait for a longer time, and yet some people are also logging in a bit slow. So maybe we'll continue as they log in. So Karen, I'll ask you'll just answer me on the chats that did the students get the notes I sent in the morning? Karen, you can just answer. I sent to the class email, or anyone, because I think it was the class email. So whatever you saw there, it was BMB 1203, Biochem 1, Biochem 2, sorry, lecture 1. Yes, I can see. Thank you, Karen. So what I'm going to do, I told Karen to send the PDF to me, or the Word document. I'm just trying to understand my students because I know their capabilities with Biochem 1. And thank you so much and Happy New Year. We are back here again. And the main objective here is we have to learn together. And the channel makes it better that as much as it's not Madam Winnie, any other student from any other university can log in anywhere, because we have to move together to make biochem simpler and understand the concepts which are difficult to crack. So from the request of the students who came to me, I thought it wise, or to be fair, to come on board in the channel. You know, the channel is where now we can understand further and we can interact. So I'll be able to explain to make it easier for you to understand, because the PDF, it can be 38 pages and maybe you don't understand. And especially the metabolic pathways, if it's not explained, it's not easy for the students to understand. So I'm here together with what the lecturer is teaching in class, we should be able to understand and pass. So what I'm kindly requesting the students, you have to attend the class, physical class. Because if you don't attend and I get a report that I'm interfering with somebody's work, then I'll not teach the online one. I'll not go to the channel and teach, because that will be unfair, even to the other person. Even me, if it were me, I won't feel okay. But now, it's not that we are undermining anybody's effort, but together with the notes which you have, and whatever I'm going to explain, I hope at the end of the semester, you'll be able to see the fruits of the struggle or the sacrifice which each of the students gave. So it's not like we are forcing somebody to come on board. For the few ladies who came to my office, maybe they were representing the whole group, but maybe someone feels they're getting, that's also okay. But everyone is free to come on board and join the discussion. So whatever involves Biochem 2 is metabolism. Using structures, you are going to describe a pathway, how important the pathway is. It is going to involve the enzymes and definitely some of the defective, or when the enzymes are defective, it leads to some diseases. So in such a case, we are going to start with carbohydrate metabolism. And you talk about the carbohydrate metabolism, we are going to look at the glucose, just as the D-glucose, the way we saw it when we were doing the monosaccharides, the simple structures which we learned in the biomolecules, is going to help us understand how those simple sugars, their degradation and synthesis is going to help in the whole pathway. So we are going to start with the glycolytic pathway, because from the PDF which I saw, the lecturer talks much about the glucose oxidation. So it starts straight by the glycolytic pathway. But what we have to note here is, before we talk about the glycolysis, where does the glucose originate from? So in the morning, mostly in the morning, I can talk about in the morning because everyone has to take food which is rich in carbohydrates so that it can provide energy, of course. But in the morning, you can't miss taking bread, maybe cassava, maybe potato. Those are starch. We learned about starch in Biochemistry 1, where you looked at the component of starch, we had the amylose and amylopectin. But whatever we saw in starch was the alpha D, which is in there, very important. But at this point, we are talking about the D-glucose, which now is a polymer, which forms the starch. So at the time you're taking starch, or you're taking that carbohydrate component in the morning, or at that time which you take that carbohydrate, the first part is the digestion. So metabolism involves 5 processes. There is digestion, there is absorption, then there is degradation and synthesis, and lastly excretion. So in the slides, and as well as in the PDF, you go straight to glucose oxidation, which is glycolysis. But let's see what happens until we have the D-glucose, which starts with glycolysis. So you have that starch, mouth. Digestion of carbohydrate starts in the mouth. The salivary amylase at a pH of 6.7, because we said the factors affecting enzyme activity. We talked about pH in Biochemistry 1. Each of those enzymes have its specific pH, optimum pH at which it works best. So for the carbohydrates, you find the salivary amylase as 6.7, almost the neutral. Then it will escape the stomach because stomach is acidic. Carbohydrate is not digested in the stomach because of the acidic pH of 1.7. Then it goes to the small intestine. So in the small intestine, it will find, well, now it has been broken down to maltotriose, the maltoses. And you know very well the maltose. Specifically, I was talking much about the alpha D glucose and the beta D glucose, but the most important point here is the maltase as an enzyme will break the maltose into 2 D glucose units. So at that point, you're talking much about the maltase. You could still remember the specificity of enzymes. And it was falling under the what? You can still remember whether it's reaction specificity or group specificity, but at group specificity, it's going to work on the glycosidic bond. So it is going to break our maltose to 2 of the D-glucose units. But then, after digestion, it follows absorption. The D-glucose is absorbed by active transport, contrary to fructose, which will be absorbed by facilitated diffusion because of the keto group at carbon atom number 2. So after absorption by active transport, then glucose oxidation will take place. So glycolysis will come after digestion and absorption. So we will have D-glucose. Remember, optical specificity of enzymes, still we learned that one in Biochemistry 1. Specificity of enzymes. In carbohydrate metabolism, the enzymes are going to work on D forms, the D sugars. Only in amino acid metabolism is when you are going to work with the L form. So we talk about the optical specificity. So we already have the D-glucose. In the PDF, it was drawn in Haworth projection, in cyclic form. In mine, I've drawn it in linear form. because I'm talking about D-glucose. I'm the one who taught that when you see D, it is drawn in linear. So you have to draw the cyclic form, as you can see it, how the lecturer drew it. So when you start with the D-glucose, now it has been digested, absorbed. I hope you are referring now to the lectures which I sent, because I said everyone is going to project maybe on a laptop as you listen, because I don't know how to project on YouTube. If I could, I could make it simple. So, oh, Nakaya, you are there. Sorry. I've already started talking. Peter, welcome. So, the D-glucose, after digestion and absorption, the D-glucose has to undergo glycolysis, breakdown. By definition, glycolysis is breakdown of glucose to pyruvate with the main objective of generating energy in form of ATP. So you are breaking down D-glucose and you are going to form two of the pyruvates. So that D-glucose, which has been generated from the digestion to absorption, undergoes glucose oxidation. You start with your D-glucose. We drew glucose in our first biochemistry 1. So it is very simple because glucose is an aldoic source, still naming of monosaccharides based on their functional group and the number of carbon atoms. And I told you D, the OH at carbon atom number 3 has to be to the left-hand side and you balance with the hydrogen. So if it is me, I always say using structures, discuss. Using structures. So you have to put structures and the correct enzymes. You can't put a reaction which is catalyzed by transferases and now you put an oxidoreductase. That is wrong. It is better you leave out the name of the enzyme if you can't remember it. That is me. I'm talking about myself. But you will use structures. Using structures, discuss glycolytic pathway. So you start with D-glucose. But still, in this glycolytic pathway, remember we are breaking down D-glucose to pyruvate with the main objective of generating energy in form of ATP. It has 3 stages. Some books talk about phases. I talk about stages. Stage number 1, you are destabilizing the D-glucose, such that stage number 1, we will have step 1 to step 3. At the end of stage 1, you will end up having fructose 1,6 bisphosphate. Stage number 2, the main objective is to generate the 2-trioses. Stage number 3 is what accomplishes the main objective of glycolysis, because we have to generate energy in form of ATP. But then, aside of those 3 stages, we have reactions which we are going to meet of the 10 steps. You have phosphoryl shift, you have phosphoryl transfers, you have isomerization, you have aldol cleavage, dehydration, all those. We are going to meet them in glycolytic pathway. So the first step, or stage 1, has step 1 to step 3. So they talk about glucose being converted to pyruvate with the main objective of generating energy in form of ATP. And then it comes in the cytosol. So if you've done cell biology, you'll know the organelle cytosol, the liquid part where most organelles reside. That is the cytosol. So it takes place in those organelles. In my introduction, I talked about the organelles, how we talk about biochemistry as chemistry of life. What is life? Cell, the basic unit of life. But then the cell can't exist without organelles, and the organelles can't exist without the metabolic pathways in them. So the cytosol is where glycolytic pathway takes place. So you are only going to meet the 3 carbons and 6 carbons, the trioses and exoses only. But then I've mentioned that the reactions you are going to meet here will have the phosphoryl transfers where the kinases are involved, the phosphoryl shifts where the mutases are involved, the isomerization where the functional isomers are involved. You know, the functional isomers as we define them in biochemistry 1. So you are going to see a conversion of a ketose to an aldose and aldose to a ketose. That is an isomerization where the isomerase is going to catalyze. There are 2 places where the isomerization takes place. So you're going to see that there is dehydration at step 9, removal of water, and then the aldol cleavage at the point where the 6 carbon, the fructose 1,6-bisphosphate, is cut into half, is cleaved to give us 2 of the trioses, that is the aldol cleavage. So you are going to see each of these reactions at what step. But the most important thing is you should always remember at what point is glycolysis as a pathway. Very important. The body is at what state? So you talk about there is enough of the glucose is too much because you are now breaking it down from the carbohydrate component you are eating. So it has to be broken down, and then we have our glucose. So the glucose is excess. So by the time glycolysis is taking place, even the glycogen synthesis takes place, glycogenesis. Excess of those glucose is stored as glycogen. And then some of those intermediates of the glycolytic pathway, like the dihydroxyacetone phosphate, will go to lipid synthesis. Even the glyceraldehyde 3-phosphate, if you already have enough of the ATP, it can't proceed to stage 3 now. It can also go to lipid formation. So we have lipogenesis. We also have glycogenesis at the time when glycolysis takes place. So at that time, insulin as a hormone regulates the pathway. And then it means at that time, the enzymes which are going to catalyze the irreversible steps are also activated. So let's see what happens in glycolytic pathway. Step number 1. I'm not going to take much of the time because you need to swallow these things slowly by slowly, such that next time when we meet, we remember whatever we did last time, and then before we can move to another pathway or to another topic, it means we have to revisit whatever we had last time. So if you look at the glycolytic pathway, you start with D-glucose. Remember, we are breaking down D-glucose to 2 of the pyruvates with the main objective of generating energy in form of ATP. So the first step in stage 1, I said stage 1, we have to destabilize our D-glucose. By destabilizing, it means at the end of stage 1, we no longer have D-glucose, but we have another product. So in this case, the D-glucose is going to be converted to glucose 6-phosphate. That is the first step. D-glucose converted to glucose 6-phosphate. What is funny about these structures is the change is only on 1 carbon. And in this case, the change is on carbon atom number 6 of glucose, which has been phosphorylated. You can remember the class of enzymes called transferases, whatever we wrote in our biochemistry 1. They will transfer the phosphate there. So the phosphate is transferred to carbon atom number 6 of glucose. You will have glucose 6-phosphate. That first step is irreversible. The enzyme which catalyzes that step is exokinase. it is not glucokinase as we talk about the substrate specificity, because in this case, the hexokinase has high affinity for glucose than the glucokinase. So it is hexokinase. But it's different from the fructose, where you are going to see the fructokinase, and also different from galactose, where you are going to see the galactokinase. So in this case, the hexokinase has high affinity for glucose than the glucokinase. So we are going to convert D-glucose to glucose 6-phosphate. A phosphate is transferred to the carbon atom number 6 of glucose. We talk about phosphoryl transfer. That step is an ATP utilization step. It goes in, if you look at that arrow keenly, it goes in as adenosine triphosphate. Still, the use of the nucleotides, very important. The bases, the adenines, it has to surround it by the phosphate. They are the source of energy. So if it's surrounded by 3 phosphates, we talk about triphosphate, and then it goes 1 phosphate less, adenosine diphosphate, it means 1 phosphate has been used to phosphorylate our glucose at carbon atom number 6, and you have glucose 6-phosphate. So that first step is irreversible. Step 1 is irreversible. The kinases at their active site need magnesium ion or manganese. Don't write both. The kinases, where you can see the phosphoryl transfer taking place. You know, the kinases, their opposite is phosphatase. Phosphatase removes a phosphate, but phosphatase are hydrolysis. Phosphatase will remove a phosphate group, but the kinases will add the phosphate group. So the kinases need manganese or magnesium ion on their active site to work. So in this case, we have an irreversible step at step 1, an ATP utilization step, the hexokinase, and at that point, we are talking about a phosphoryl transfer. Then, from glucose 6-phosphate to fructose 6-phosphate, step number 2, we are still at stage 1. The main objective of stage 1 is to destabilize our D-glucose. Step number 2, we are converting an aldohexose to a ketohexose, and also a ketohexose to an aldohexose. So step number 2 is reversible. The enzyme will get the name from the reaction it catalyzes, and mostly it will get a name of the substrate. The substrate here is glucose 6-phosphate. So the name of the enzyme is phosphogluco, because the glucose is phosphorylated. But then the reaction involves isomerization, because glucose and fructose are functional isomers. So you talk about phosphoglucoisomerase. But bear in mind, step 2 is reversible. There is a reason why I'm stressing on the irreversible steps, because by the time we reach gluconeogenesis, we are talking about the body is on starvation. So there is no glucose. It has to look for glucose from the non-carbohydrate precursors. It means the irreversible steps we will be bypassed. So like we'll have another enzyme apart from the one which has been known. But the reversible steps, the enzyme will remain the same. Only the direction of the reaction will go towards the synthesis of glucose. So I'm stressing on the irreversible steps because they're very important. At the time we are talking about gluconeogenesis, we'll be able to highlight the enzymes in the bypassed steps. So glucose 6-phosphate converted to fructose 6-phosphate, then fructose 6-phosphate to glucose 6-phosphate is an isomerization step. It is reversible. The enzyme gets the name from the substrate, which is glucose 6-phosphate, phosphogluco. It's an isomerization, so it is isomerase. We are still in stage 1. Step number 3, we are converting fructose 6-phosphate to fructose 1,6-bisphosphate. It is an irreversible step. The enzyme is a phosphofructokinase. The kinases still need magnesium ion or manganese ion to work. So it is an ATP utilization step. If you look at that arrow, the way it was entering. So now our fructose 6-phosphate is phosphorylated as well at carbon atom number 1. So we have 2 carbons at carbon atom number 1 and number 6. Phosphorylation takes place. So it comes in as a triphosphate, goes out as a diphosphate, because 1-phosphate has been used to phosphorylate our fructose 6-phosphate at carbon atom number 1 to form fructose 1,6-bisphosphate. That enzyme phosphofructokinase, remember the kinases are the ones which do the phosphoryl transfer. That step is a phosphoryl transfer. At that point, you talk about the PFK or the phosphofructokinase as the rate limiting step. At that step, it's also an ATP utilization step. That step is also irreversible. So, step 1, 2, and 3 are part of the stage 1. What you also have to note here is we have to destabilize our D-glucose in stage 1 so that we end up getting fructose 1,6-bisphosphate. Stage 2 involves step 4 and step 5. And the main objective of stage 2 was to generate the 2-trioses. We are talking about the 2-trioses. If you look at the structure of fructose, if you are on your slide, if you cut that fructose 1,6-bisphosphate into half, the upper part you will have dihydroxyacetone phosphate, which is a ketotriose. Then, the lower part, you will have glyceraldehyde 3-phosphate, which is an aldotriose. The interconversion of an aldotriose and a ketotriose involves isomerization. The enzyme is called triose phosphate isomerase. They are both trioses. They are both phosphorylated, but it's an isomerization step. So we have triose phosphate isomerase. That is step number 5. So step number 4 is where we are cleaving. The aldol cleavage occurs at step number 4. We are cleaving our 6 carbon atoms to 2 of the 3 carbon atoms. And that is the main objective of stage 2, to generate the 2 trioses, because one of the triose is the one which will lead to the stage 3, where ATP will be generated. So, stage number 2 involves aldol cleavage at step 4, involves isomerization at step 5. Remember, we had another isomerization in stage 1, where we had the phosphoglucoisomerase catalyzing it. So based on how they set their questions, somebody can ask either stage 1 or stage 2, or using structures, describe the isomerization steps in glycolysis, or the isomerization step in stage 1, the isomerization step in stage 2. We've already destabilized our glucose. We've already broken down into 2 of the trioses. So the main objective of glycolysis is it has to generate energy. Just as the role of carbohydrates come handy. Source of energy, very important. So the stage 3 Where we have step 6 to step 10 is where the generation of energy is going to take place, specifically at step 7 and step 10. So, the step number 6, very important. The only oxidoreductase involved in glycolytic pathway is step number 6. So, stage number 3, we have to generate energy in form of ATP. That is the role of stage number 3. So stage number 3 has step 6 to step 10. At step 6, the only oxidoreductase which is involved in glycolytic pathway is glyceraldehyde 3-phosphate. So we say the dihydroxyacetone phosphate, nothing gets wasted in glycolysis. In fact, it has a role which it plays. It is playing an amphibolic role. So it provides materials for other pathways. Its intermediates are used as materials for other pathways. If you talk about the glucose 6-phosphate, which is used in the hexose monophosphate shunt or pentose phosphate pathway, it's from glycolysis. If you talk about the 3-phosphoglycerate, it is used much in the synthesis of serine. You get now the dihydroxyacetone phosphate, it goes to the formation of the glycerol or the lipogenesis. A lot can be used. Yes. So even the 1,3-bisphosphoglycerate can also be converted to 2,3-bisphosphoglycerate, which help much in oxygenation of those erythrocytes. So that's how important it is. So in this case, nothing gets wasted. The dihydroxyacetone phosphate can go to lipogenesis, and then we remain with glyceraldehyde 3-phosphate is the one which we proceed with to formation of pyruvate. So at stage 3, we have to generate energy in form of ATP. So the glyceraldehyde 3-phosphate, you can see, plus a phosphate, Pi. Then NAD plus is used to generate NADH. The NADH, very important, the NADH will go to the ETC, the electron transport chain. It will act as a carrier there. Yes, nothing gets wasted to provide energy as well. The electron transport chain in oxidative phosphorylation, it will be used to generate energy in form of ATP. So glyceraldehyde 3-phosphate from stage 2, the dihydroxyacetone phosphate has gone to lipogenesis or lipid metabolism. We remain with glyceraldehyde 3-phosphate. Step number 6, the only dehydrogenase in glycolytic pathway, we have the NAD plus dependent enzyme glyceraldehyde 3-phosphate dehydrogenase. And I told you the oxidoreductases, when you are doing the class of enzymes in biochemistry 1, they are catalyzing oxidation reduction reactions, if you can remember that. So if you see the NAD plus, the NADHs, or the NADP plus, the FAD plus, most of them are dehydrogenases. It's easier to tell the name of the enzyme. So it is going to convert our glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate. You can see the structure of 1,3-bisphosphoglycerate. I told you only one carbon is affected. So the first carbon now has a phosphate, and then we have the double bond O. So it's only the hydrogen which is removed. Carbon atom number 2 and number 3 remain intact for you to form 1,3-bisphosphoglycerate. So it is glycerate. The glycerate comes about because C double bond O, at carbon atom number 1. Then the main objective of stage 3 was to generate energy in form of ATP. So at step 7, the first step where ATP is generated, and the ATP generation step, you also refer to them as substrate phosphorylation steps. So if you talk about substrate phosphorylation, There are those steps where the ATP is generated. So the first step where ATP is generated is that step number 7, where we involve the phosphoglycerate kinase. You can see the arrow goes from ADP to ATP. We have magnesium ion still for the kinases on their active site, but then the step is reversible. We are forming 3-phosphoglycerate. I told you, these 2 intermediates are very important. The 1,3-bisphosphoglycerate is going to another pathway to form 2,3-bisphosphoglycerate, which are used much in oxygenation of those erythrocytes. We'll be able to look at that pathway with time. Then the conversion to 3-phosphoglycerate is used as one of those precursors in the formation, in the synthesis of serine. It's used as a material in the synthesis of serine. So that's how important glycolytic pathway is. Some of the intermediates are used by other pathways. So step 7 is the first ATP generation step. Look at the arrow. There is ATP which is generated. It comes in as a diphosphate, goes out as a triphosphate. Then step number 8, phosphoryl shift. We talked about the reactions which you are going to meet in glycolytic pathway. Mutases, where there is mutation. We talk about frame shift in molecular biology. That is a form of mutation. So just from the name, the process which involves in that step is mutation. So the shifting, the enzyme will be mutase. So it gets the name from the substrate, which is phosphoglycerate. So phosphoglycerate mutase will be the enzyme. It now shifts the phosphate from the 3rd carbon to the 2nd carbon. So you have the phosphoglycerate mutase. Dehydration step. If you can't remember the intermediate, put your arrow straight from the 2-phosphoglycerate to the phosphoenol pyruvate. So that step number 9 is reversible. So you go straight from 2-phosphoglycerate to formation of phosphoenol pyruvate, and you can see the formation of a double bond. Just remember the class of enzymes which we discussed in Biochemistry 1 and their specificity. You'll be good to go. You'll know the reactions which all these enzymes are catalyzing, and it will help you to know much the name of the enzyme which is catalyzing that step. So in this case, we have enolase because it is a dehydration step. We are removing water. In fact, we are removing water at carbon atom number 3. Nothing changes. What changes is carbon atom number 3. And the changes are, if you want to master it easier, the hydrogen at 2-phosphoglycerate at carbon atom number 2 and the OH at 3rd carbon atom is what is released as water. Then I told you to balance these bonds. If there is a double bond there, you have to balance bond around the carbon to be 4. That's how simple it is. So you have the phosphoenol pyruvate. At step number 9, there is dehydration. The last step is an irreversible step. ATP generation step. The second step where ATP is generated. Pyruvate kinase catalyzing the enzyme, And I said that whenever the kinases work, the magnesium ion or manganese at their active site has to be present. So ATP is generated. You can see it goes towards formation of ATP. We've already formed our pyruvate. And you know, when you're going to look at some of the diseases which relates to the defects of the enzymes, there is a disease which involves the muscle weakness here, pyruvate kinase. When that step, the enzyme is defective, it brings problems. The ATP production won't be enough. So the muscles will be weak. So at that point, the defects on those enzymes on that pathway, we should also understand so that it can make us understand how important those enzymes are when they work correctly. So at that point, we have the ATP generation step, the last irreversible step, and we are forming pyruvate. So stage 3 involves step 6 to step 10. The main objective of stage 3 is to generate energy in form of ATP. And in step 7 and step 10 is where the substrate level phosphorylation steps are, the ATP generation steps. So we've learned stage 1, we are destabilizing our glucose and we'll end up having fructose 1,6-bisphosphate. In stage 1, we have 2 of the irreversible steps, step 1 and step 3. Step 1 catalyzed by hexokinase, step 3 by phosphofructokinase. And remember, those steps, step 1 and step 3, they are both ATP utilization step. They are irreversible. The kinases are catalyzing those steps. We need magnesium ion or manganese. Stage number 2, we are generating the 2-trioses. The fructose 1,6-bisphosphate is broken down to dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. There is an aldol cleavage at step number 4, isomerization at step number 5. One of the trioses, dihydroxyacetone phosphate, will go straight to lipogenesis. The glyceraldehyde 3-phosphate will go to stage 3 to provide energy in form of ATP. So we'll be able to generate energy, step 7 and step 10. Step 7 is reversible. Step 10 is irreversible. So generally, the glycolytic pathway in glucose oxidation, we have 3 irreversible steps. Step number 1, number 3, and number 10. And glycolysis takes place when the glucose levels are high. So it means at the time glycolysis takes place, even glycogen synthesis takes place. Insulin regulates glycolytic pathway. At that point, when insulin is regulating those pathways, the active enzymes which catalyze the irreversible steps are hexokinase, phosphofructokinase, and pyruvate kinase. I'll stop. So, I'll stop. You people go and read and check with the PDF which you are given, which the lecturer gave you. You see if now you can understand on your own as you read, as you look at the structure, as you read the notes, you try to relate, then we shall organize again when we need to meet. I'll introduce them slowly by slowly. Before you can do your cuts, then you let me know. Then after the cut, I will see if the lectures on the channel really helped, maybe. So I'll leave you to go because tomorrow you have a class. We'll discuss with Karen, or Karen will discuss with me, you people, how you want it. One of the weekends, you are the one now to tell me if you need it. If you think it's not necessary, also I'll stop. So you'll have to tell me if it's necessary, then I'll come on board and proceed with carbohydrate metabolism. But you have to attend class, please. Attend the physical class so that you can get what the lecturer is teaching and then relate the notes with whatever is in the slides together with all those resources which you have. You'll be able to pass because we have to put an effort in everything. We have to put an effort. Yes? So I say thank you and you can have a good night. It's already 10. I promise just to take 1 hour. I don't like to take more. So you can go and read and try to understand. You'll get back to me through Karen. Maybe Karen will be able to inform me much on what we need to do. But we are still together. I know you can make it. because you are very hardworking students. I know you people. I don't want anybody to get lost, and let your heart not feel that you've lost it. No, the fight has to continue. The struggle has to continue. It doesn't matter whoever teaches. As long as if you request me, I'll be available. I'll be available to make you understand. We'll be available to revise, because our target here, we have to pass. We came to meet the career of our dreams. You came to be nurses, so you can't live along the way because you feel disappointed. No. So we have to, together we have to do this. So let us work together and let us keep in touch. I'm still available. It's good. We can still meet on channel and we'll be able to highlight that which we don't know, especially at preclinicals. If it's biochemistry, I'll be able to come in where I can. So thank you and may God bless.